Hello and welcome to another lesson about formal language theory. In the last video we talked about, we started talking about the question of how to be able to tell whether a language is regular or not if you're not given a regular grammar for it. And in this lesson we're going to continue talking about that by talking about infinite regular languages. So remember, we already concluded that any finite language, any language with a countable number of members in it, is going to be regular. And there's a number of reasons for that. So go back and watch that video if you want to remember that. This one is about how you go about creating infinite regular languages and what the sorts of languages that you create that way look like. All right, so first remember that when we're looking at our definition, our recursive definition of a regular language, the set containing a single string will be your base case, and then any of the following operations can be used to create something that is also a regular language, right? So A union B will create a regular language, the concatenation of A and B will create a regular language, and clean star of A will create a regular language, but the union operation and the concatenation operation can only create finite regular languages, right? Because if you feed it finite sets, they can only create finite languages. So the only way to introduce infiniteness, non-finiteness, into a regular language is if some portion of the regular language is clean starred. And we'll talk about we're going to talk about the clean star and the types of languages that are produced when you use the clean star in this video. So the first case that we can look at is the simplest case, where we have a set A, which contains a single string, AB, right? And we're going to take the clean star of this set, right? Clean star of A is going to be, let's use red, the set containing AB, or AB, AB, or AB, AB, AB to infinity, right? So you're essentially treating this as one chunk, and we can repeat that chunk in whatever orders we want as many times as we want, right? So we can't tell if this is, what order we're repeating the chunk in, but the chunk is getting repeated in different orders, right? Now let's look at a slightly more complicated case where we have two sets. We have a set A, which contains the string AB, and a set B, which contains the string CD. And we want to take the union of those two sets and then clean star them. So first of all, what is the union of these two sets? The union of these two sets is AB, CD. Right, so this can also be an example of if you have a regular language that you're just given, right? So we could call this language C and then clean star it, right? So it's the same thing as looking at a language with multiple members. So in this case, we can take these strings and repeat them as many times as we want and in any order that we want, right? So we could have just AB, right? So that's one repetition of AB and 0 repetitions of CD. Or we could have CD, which is 0 repetitions of AB and 1 repetition of CD. Or you can combine them, A, B, C, D, right? So that's one of each. You could put them in a different order, C, D, A, B. Or you could just repeat one of them a zillion billion times, right? Or you could repeat one of them once, C, D, C, D, A, B, A, B, C, D, right? We can just put them in any order that we want. As long as we keep this together and we keep this together, that's all that matters, right? And these will produce infinite sets. All right, let's look instead at what would have happened. I'm just going to erase part of this so we have some more room. If we clean starred A and then unioned it with B, right? So what would this look like, right? So we've already figured out what the clean star of A looks like, right? We have AB, 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 and then union it with B, which just means also includes CD in the set, right? So it's going to be exactly the same as clean star of A, right? So we're going to have AB, 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 blah, blah, blah. And then somewhere in the set we have CD. That's the only difference, right? So there's a subset of this, right? So in this case, the whole thing is clean starred, right? In this case, we've got only a subset of it clean starred, but a subset of this is just going to be A with a clean star, right? A with a clean star, right, is a subset. And similarly, A with a clean star is a subset of this as well, right? We can have infinite AB, 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 right? These are all these are all members that are also members of this set, right? So every member of the clean star of A is also a member of the clean star of the union of A and B. Every member of the clean star of A is also a member of the clean star of A union B, right? So we're starting to see that you've got at least one substring that can be repeated at least one string that can be repeated infinitely within each of these sets. All right. So let's look at a slightly more complicated case where we're going to do concatenations this time, right? So let's say we have a string A and a string B, and AB, we're going to take AB and then clean star it. So first of all, what is the concatenation of A and B? We take all the members of A, which is just one, and concatenate them with each of the members of B, which is just one. Right, so that's going to be our concatenation of A and B. And now we're going to clean star that. So just like when we clean starred this string up here, right, we're going to say A, B, C, D, 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 and so on and so forth. You can repeat it as many times as you want and in any order you want, but we can't tell if we've only got one member. You can't tell what order you're putting the things in, right? All right. So how does that differ from a concatenation of B star, right? So first of all, what does B star look like? B star would be the set containing CD, 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 C, CD, 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 and so on and so forth, right? And so A concatenated with that, we're just going to take this and stick AB on front of each of those. Right? So notice that we've got sort of two separate things going on, right? So we're not gonna be able to if we are just looking at these sets, right? If we couldn't see the formulas that we're using to create the sets. In some cases, not every member of the set will be part of the clean starred part, right? So for instance, in this case, we've got some finite portion here that's not been clean starred, right? In some cases, not every part of the string is going to be part of the clean starred part, right? So we've got some pieces of the string that are fixed, right? And then we can repeat the rest of it as many times as we want. Right? So we've got two different notions here, right? So the first notion is a substring, which is some portion of a string. And you can say that any portion of a string is a substring, right? So AB is a substring, CAN, I think that's supposed to be a QR, is a substring, right? We can select any piece and those can be substrings, right? So this is an important thing to have knowledge of, is what a substring is. And then we've also got the notion of a sublanguage, which is just a subset of a language. This is just how we talk about subsets when we're talking about languages. So in some cases, the clean starred portion is going to be the part that you can just repeat over and over again. We're repeating a substring, as many times as we want within at least some sub-portion of a language, right? So repeat a substring within a subset. Right, so that's what's going to hold these. That's what's going to cover all of these cases where we've used a clean star. That there is some subset of the language where we are just repeating a substring as many times as we want to infinity. Right. So what does that mean? It means that there is a sublanguage of every regular language that is infinite that looks like this. Right, where we have some portion A, we don't even care what A is, but we can fix that portion, right? So at some point, we're going to fix a portion A and a portion C on the other side. These could be empty even, right? But they're anything that we've decided to fix in place, right? And there will be a portion B in between those, and you can repeat that portion B an infinite number of times. So what does this look like in a in a finite state automaton, right? We have a start state. We're going to go here, and then we're going to end, right? Let's just look at this top portion for now, right? So if we start here, we go here, and then we go back here as many times as we want, right? And then we end, right? So if we put labels on these, let's say this says AC, and this says B, and this says D, right? So the strings you're going to produce are A, C, B, and this says F, for example, right? We're going to produce A, C, B, D, or we'll produce A, C, B, F, B, D, or A, C, B, F, B, F, B, D, right? And so on and so forth. So it's this little portion, FB, that is going to be reproduced as many times as you want. Now you could have a whole nother path to go through, XY, right? And this is just going to be finite, right? Right? This doesn't include any of that stuff. It's finite. We could even have another path that you can go through that has a clean starred portion, right? So this is another path you can go through that's infinite, right? All that we care about is that there is some path that looks like this within your language, right? And that's what this means, right? So this is the part of the path that loops. That's what this B is the looping part. And this is part of your path that doesn't loop, or that you've decided to only follow the same loopy path through, right? Just for this purpose. And this is essentially all the thing we're going to introduce in the next video, the pumping lemma. This is what the pumping lemma says, is that you can do this, right? You can fix two pieces on either side of a repeating piece. That's all that the pumping lemma says, and this is what's going to help you identify which languages are regular and which languages are not regular, is that in a regular language, you can fix these two pieces and then repeat an internal piece. In a context-free language or a context-sensitive language, you can't do this for every string, right? You might be able to do it for some, but not for all. All right, so this has hopefully helped you to understand a little bit better about how clean star works, so that when we introduce the pumping lemma in the next video, it will make more sense. So tune in for that.